I'm one of the co-founders of Mowea, and I brought you this slide and I have a question. What do you see here? Actually, you see not much, but a village in Maharashtra, that's an area in India where about 2 million households live with limited access to grid electricity. And we cannot really think about it, but actually that's true for about 1/4 of our global population living in off-grid or in bad grid situations, which simply means the people have no grid, they cannot plug in any electronic device, have lamps or whatever. So, living under these off or bad grid conditions is actually dangerous and expensive. And dangerous because indoor kerosene lighting alone causes over 60% of death among children under the age of 5. Moreover, it's emitting every year millions of tons of CO2, and globally these people spend about $30 billion for fossil fuel solutions or for charging battery services. Addressing these problems, you can find nowadays millions of solar home systems that are sold, for example, in the Indian market. They can produce 10 to 150 watt, come with a small electronic device often and with a battery, so you can have a lamp or you can charge even your radio and mobile and sometimes even TVs. And this micro solution market for solar is actually expected to grow by 60% every year and will reach in 2020 a global market of $300 million. However, so like the total decentralized market for renewables in India is much bigger. That means there's enough space for products developing more energy than 200 watt. And that is actually expected to grow to 2020 to $30 billion. Nevertheless, solar alone is not solving the problem, as it's still not overcoming the energy shortage at night, during rainy seasons, and in times with a lot of dust in the air. And this is why wind can actually complement solar and help overcome these energy shortages.
Thank you, Lara. My name is Till, and this is where Mowea comes in. We developed a modular micro-wind-energy system, and we know there are still some competitors on the market, but they have two big problems. The first problem is they are very expensive, and the second one is they are not efficient enough. And I will tell you how Mowea solved those problems and give you a short overview about our USPs. The first one is according the efficiency. Our turbine is optimized for very low wind speeds, and we have a totally new aerodynamic concept which is based on my PhD thesis, and we use a brushless DC generator, which is an automotive product, still mass produced and very efficient, and we developed a totally new maximum power point tracking controller for the operating of the turbine. According to the costs, this turbine is constructed as simple as possible. We have no complicated mechanical things inside, no gearbox, no cooling system, no things to change the angle of attack or something. So we will guarantee a long lifetime of our product. And almost every part of this turbine will be produced by injection molding to make a mass production and to reduce the costs. Last but not least, we have a modular setup, so it's possible to combine up to 3 of those turbines on one tower and combine all the nominal powers to run to one resulting nominal power up to 1.5 kilowatts. Last but not least, micro-wind energy system can be installed to almost every existing solar PV system. So there are millions of small solar PV systems already existing with a controller and a battery system, and we are able to go plug and play to those systems. The next steps of the development will be to make this turbine system smart. We want to develop an energy and communication hotspot and prepare those micro-energy systems to be integrated into microgrids. This will be the future of the first and second steps of electrification. I think this is an overview of the technical things, and Lara will go on with some market details.
Thank you. So what we identified as a business model to reach the end customer in remote areas is a B2B business model. So we have in the team the skills to design the turbines, but we will outsource the production to partners and will then pre-assemble the product again in Berlin. Then we will sell the product to off-grid resellers who are located in Germany but sell especially in India and Africa, and some of them even international. In the last month we have found our first 3 partners. I shortly introduce them. Fosera is a German-based solar home system reseller. They work especially in India and Africa. Then the BOS AG, they produce battery systems for off-grid areas. They are also in Germany but sell especially in India. Then we have Microenergy, an energy consultant who is an expert in microgrids and help companies to install microgrids internationally. And last but not least, we have an LOI of Faeson, the biggest off-grid reseller in Europe. These partners will sell our product through their channels to the end customer, who can afford our product through pay-to-go models. Going to the market, we have chosen the so-called Tesla strategy, which means we want to come from a high-tech, high-budget to a high-tech, low-budget product. Therefore, we start in Germany with our prototype, which you see here. It's a working prototype. We do now a field test. Next year, we will have our first paying customers in Germany, just to have a proof of concept. We are not targeting the German market. And then in 2018, we will invest in machineries to be able to mass produce our product and therefore be able in 2020 to enter the global off-grid market. This is the team behind Mowea. We all met at the Technical University in Berlin and are united through the passion for sustainability. Our CEO Till developed during his PhD research our innovative turbine design and is an expert for aerodynamics. Our CTO Andreas developed the electronical parts and is now responsible for the IoT solutions. And I did a double master degree in innovation management and entrepreneurship and am now developing the business model. We have received in June this year Exist and are therefore able to work for 1 year till May next year and have money for our prototype. We have now even 4 students supporting our team. We are in the process of filing a patent and we can use the facilities of the Technical University to develop our prototype. Now we are looking for industry partners and business angels to accelerate our business. Thank you.
Okay, thank you for your presentation. Other questions? Yeah, many questions in the jury?
When in a village you have, I don't know, 200-300 of those, how about the noise? Because this is the problem with those kind of turbines.
I think in those countries the noises are not that important, but we have a problem with the noise. There are much frequencies because it's quite fast rotating, but there are some aerodynamic tricks which you can reduce the noise quite good, which we apply.
Okay. I have more technical question.
Yes.
You were starting with the statement that one of your target and how you differentiate from your competitors is the efficiency.
Yeah.
I understood that you didn't put the changeable geometry of the thing because of the robustness and because of the durability and so on, but then you lose the efficiency. Is it really impossible to do the changeable geometry of the blades without affecting the lifetime and the durability and so on?
I think it is. We have already some experience about the injection molding to find or to get a real exact geometry, and I did almost 5 years of research to increase the aerodynamic efficiency. Does this answer your question, or I did not get it?
You said that you optimize the geometry for the low wind, which means when the wind will increase, you lose the efficiency. It's a principle. So it's still the factor of the robustness more important for you than the efficiency?
Okay, these are 2 different points, I think. First of all, the low wind optimization is be done by the diameter. This is quite big diameter for this nominal power. And the efficiency, the aerodynamic efficiency, is based on the geometry, not on the length. So what I've done to increase the efficiency is to develop a totally new method to calculate the geometry. And I validated it during my PhD thesis.
I just thought shortly add, I think I may understand your question differently. What you think is that we cannot use in the stormy conditions, right? Because we focus on low wind. So what we actually tested already in a different research project is the efficiency, and it was from Germanischen Lloyd, I think, certificated. And the thing is that we actually use, I have to choose my wordings right, 80% of the time the wind that is there. So I was always saying capacity, that's another thing, but like most of the time you have low wind. So what we are focusing on is the right direction, because if you focus on the other way, what are the big wind turbines are doing, then they are just not rotating. They use like 10 or 20% of the time the energy from the wind, and we can 80% of the time use the energy. Whenever there is too stormy conditions, it's right, we have to stop the turbine, but that's okay because all the rest of the time we use the energy. So in the end, we can use over the day much, much more.
The operation range is between, we start at 2.5 meters per second wind speed, and we reach nominal power at 8 meters, and we end about 20 meters per second wind speed.
So you're doing field tests with a working prototype for how long now?
We did research projects before. We start now hopefully in December with our first field test.
Okay, so you do not yet have results about operating hours, how robust the system is? And
no, not
you
yet.
start doing this in December?
Yeah.
Okay, okay. Thank you.
In the audience, question.
I'm from India, and thank you for taking up the good cause.
You're welcome.
For the end user, how much will it cost? Per day, per month?
Yeah, I was saying that we want to install a pay-to-go model, so that is actually used for solar systems a lot. So you can control whenever the customer is using the product. So then the person is not paying for the product, but like energy as a service. So you can either pay a monthly rent. In Africa, for example, different competitors go with €1 per day. We will have to adjust that to every market, so how much the off-grid energy is sold there, but we will orientate our price model to that.
So let's say the state electricity board provides us with electricity at the rate of 2 rupees 35 paise per unit.
Yeah.
The grid. Against this, how much will your system cost?
You compare it with a grid price. We are not targeting grid, we target off-grid. There you have to calculate with a much higher cost because you pay for kerosene, diesel generators, all that, and you have a big hustle, a time issue, and a bigger cost. So it's not exactly the same price. And in India, we were doing a workshop with Bosch and with different energy startups from India in Berlin, and with them we found out a target price for India for a 500 watt module for $500. And we know there are open source wind turbines in India by now very popular. They are around €800, so it would be a competitive price.
One question for me. How many turbines do you need for a normal house? Is one enough, or I saw you can modulate it?
Der Energiebedarf steigt und steigt und steigt.
He was choosing the words like second and third electrification. So if you start in areas where you have no electricity at all, the first electrifications, there often people use just a solar home system which is producing 150 watt. And you can say in first place it's enough. But then they have just light, or they can charge a mobile or whatever. And you can see in research that there are like 5 layers of electrification. And if you have done the first step, it's growing dramatically. So like from the first moment you can use energy, you buy a lot of devices and you want to really scale it up. So you easily come from the first to the second layer where you need more than 500 watt. So we start with one model with 500 watt. You can have up to 3, so you have 1.5 kilowatt. And in Germany, for example, a house uses 3 kilowatt. So you can scale it up.
Okay, thank you. Thank you for the presentation. No questions anymore. I'd like to introduce Mr. Lefebvre. The next